Welcome students. Today we are going to calculate string efficiency of a insulator string. How to find out the value of potential across each string and then find out the value for string efficiency. So usually we should all know about the voltage distribution across the each string of a suspension insulator is not same. So there is a different voltage for each disk. So the disk nearest to the live wire is has more potential than far away from the live wire. So the string efficiency is defined as the ratio of voltage across the strings. That is, what is the total voltage across the string divided by n into voltage across the unit adjacent to the line conductor. So what is the value of the disk that has potential near to the line conductor? So line near to the line conductor disk, what is the potential difference? So before going to this, the important one is safety factor of insulator. That safety factor is defined as the puncture strength to the flashover voltage. Sometimes in your problem they mention the puncture strength and the safety factor. From this you need to identify the flashover voltage by using this formula. So now consider a suspension insulator has three disc of insulators. So disc 1, disk 2 and disk 3. The voltage as the disk 1 is V3, that is the maximum potential because it is a live conductor. The disk nearest to the line has more potential, so the V3 value is larger than other two. So and then second disk the potential is V2 and the third one V1. It is the least potential since it is far away from the line conductor. So now look at the formation of capacitors. So this is the insulator pin. So between this pin, so it is the earth, that is your tower. So there is a metal and a metal. So it acts as a parallel plate. So that capacitor will be formed. That capacitor you take it as C1. So again, this is second disk metal pin. So this is first disk metal pin. So between this you have an insulator. So that insulator is forms another one capacitor, that is called C. So this is same way. Again this metal pin and tower you get capacitance C1. Again this metal pin and tower you get capacitance. So these are the capacitance between your metal pin of the string insulator and the tower. This is called shunt capacitance. Similarly, the capacitance C, that is the disk, due to this insulated disk you form the capacitance between the two metal pins, that is called mutual capacitance, that is C. So usually the value of C will be larger compared to C1. So the C1 will be only a fraction of this C. So you can write C1 equal to K into C. The K value will be maybe 0.1 or 0.2. It is a very fraction, only 10% or 15% of the mutual capacitance. So we can write C1 equal to K into C. Now we will find out how will you find out the value for V1, V2, V3 from this given string. Now apply KCL at node number A. So at node A. So where is node A? Before that we'll erase all these things. Okay, now it's fine. Now come to node A. Node A. What is the incoming current? I2. From here current I2 will be incoming and the current I1, capital I1 and small I1 is the outgoing current. So what is the current flow through your capacitance? Capital I1 equal to, so what is the voltage across this? V1. So V1 into omega C plus what is small I1? V1 into omega C1. So C1 equal to K times that of C. So V1 omega C plus V1 omega K into C. So from this we can write V2 equal to, so CC cancel. So I2 equal to incoming current is equal to outgoing currents. So the capacitance formula, current flow through the capacitor is 2 pi C into Vc, or you can take it as omega C into Vc, nothing worry. So omega is 2 pi f, so omega C into Vc. So I2 become 2 pi f into CV2 because the current flow through here. So the voltage across this disk is V2. So you have to take 2 pi f c into V2 is the I2 value, and then I1. So 2 pi f C1 into V1. I1, small I1 is the capacitance in the shunt branch. So it is a small I1. So it is C1. So 2 pi f C1 into V1 plus 2 pi f C into V1. So all the time 2 pi f constant. So you cancel it. So you get C into V2 equal to V1 into C plus C1. So V2 equal to V1 into 1 plus C1 by C. So in the two terms you take C outside. So take C outside means C by C become 1. So C1 by C that term exists. So C1 by C you can say it as K because already I told K is the fractional value. So K is equal to from this C1 by C. So therefore V2 is equal to V1 into 1 plus K. Similarly, coming to node B and do the same procedure, you will get some value. So at node B, I3 is equal to capital I2 into plus small I2. So here incoming current is I3. Capital I3 is equal to capital I2 plus small I2. Using the same procedure, follow here. So I3 is the current flow through the mutual capacitance. So the potential is V3. So 2 pi of V3 into C. Similarly, capital I2 is equal to 2 pi f into CV2. Similarly, I2. So I2 is the current in this branch. So the potential at this point is V1 plus V2. So keep in mind. So V1 plus V2 into 2 pi f C1. So finally, you will get 2 pi f C1 into V1 plus V2. So I2 capital I2 2 pi f C into V2. So V3 is equal to V1 into 1 plus K square plus 3K. Similarly at node 4 I4 equal to I3 plus I3. You follow this, you will get V4 equal to V1 into 1 plus K cube plus 5K square plus 6K. And then you are so total voltage, that is the line voltage, is equal to sum of all the voltage across individual disk. So V is equal to V1 plus V2 plus V3 plus V4. Suppose I will take assume K is equal to 25% of that shunt capacitance which mutual capacitance, then we will get V2 is equal to 1.25 V1, V3 is equal to 1.8 V1, V4 is equal to 2.8, V is equal to 6.8. So approximately roughly you get 60.91% of your string efficiency. So here look at the voltage at individual disk will be different with respect to each other. So if the value is greater, K is greater than more non-uniform voltage distribution across it. So you will get only less string efficiency. So it may leads to puncture very easily. So the inequality of voltage distribution increases with the increase the number of disks in the thickness. Therefore, the string has shorter length has more efficiency than longer one, because if you have increased the number of disks, automatically the potential distribution across each string is also gets increased. Thank you.